Light Lab here. So you're first going to click on the intro button. That's the version of the lab we want. You see here we have a laser pointer and a boundary between two surfaces. Initially it's set to air and water. First thing you're going to do is drag your protractor out here, and you want to make sure that this little notch here, basically right in the middle there, lines up with the intersection of the dotted line and the boundary. So something like that, because the laser pointer is going to shine in at that center point, and that's going to allow us to properly measure the angle. So for the first part, you're going to change the angle to 30 degrees here. You will see there's one ray that hits the surface and bounces off. That's going to be called the reflected ray, because it reflects off the surface. The other ray goes through, but as you see it bends a little bit. That's going to be called the refracted ray. So you're going to be using your protractor to get the angle here. Now the angle is always going to be measured from this dotted line, and that's how the protractor is set up. We call this the normal line, but this would be the 30-degree angle here. Obviously each one of these small tick marks is 5 degrees. The bigger ones are 10. So this would be 10 degrees right there, and then 20, 30, 40, 50, 60, etc. All right, so you're going to be measuring the angle each time of the ray that's going in, called the incident ray, the reflected ray, and the refracted ray. Sometimes you will change the material. You can do that just from this drop down here. Okay, you can change the material of either one. And each one you'll see has this index of refraction measurement here. We're going to talk a little bit more about that later. But basically that's a measure of how slowly light travels. So the bigger the index of refraction, the slower it is. So we're not going to do a ton with glass in this lab, but you see glass is even higher than water. It means glass travels slower. Light and air travels faster.